All right, good morning. Today we are going to do a little bit of review that ties into the new stuff that we're learning. So we're going to review about cold fronts. So if you remember, cold fronts are symbolized by the little blue triangles. They are pointing the way that they are moving. So in this case, this cold front is moving down the board. Cold fronts bring colder, drier air behind them. So if this is a cold air mass, it's moving this direction. This air behind it is colder and drier. This air in front of it is warmer and more moist. So as it comes in, it forces this warm, moist air up. And we know as things in the troposphere go up in altitude, they decrease in temperature. So all of the moisture in that warm, moist air starts to condense from water vapor into water droplets, and we get big rain clouds. So cold fronts move quickly. They tend to move more quickly. So as that warm, moist air is rising, because that cold air is forcing into it, that's happening very quickly, so we get some pretty violent storms. So we get heavy rainfall for a very short period of time. Okay, so warm fronts, and we symbolize them with the red semicircles, which are pointing in the direction that they're moving. Warm fronts bring warmer, more moist air behind them. So this little mass of warm air is moist, and it's bringing it towards the cold air. It's running into that cold air mass. So these tend to move a bit more slowly than cold fronts. Warmer air is less dense, so it's going to run into this cold air mass, and then it's going to rise above the cold air mass. As it's pushing the cold air mass out of the way, it's going to kind of rise above it as it's pushing. So that warmer, more moist air is rising a little bit, and as it rises, it gets up higher in the atmosphere, it cools, the water vapor condenses and turns into clouds, and then those clouds release a little bit of rain. So it happens pretty slowly compared to a cold front, so we're going to get longer term but lighter precipitation. And then we have our friend, the stationary front. So the stationary front is not moving anywhere anytime fast. So we have our warm, moist air and our cold, drier air, and they're kind of at a standstill. So at the boundary, we have a little tiny bit of warm air rising up, and as it rises, the little bit of warm air is rising, it cools, the water vapor condenses, turns into little bitty clouds. So we have really long periods of cloud cover and drizzle for a very long time. So it's very light precipitation, but for a very extended period of time. And remember, when we draw the symbol for this, we have our red semicircles facing our warm air mass, and our blue triangles facing our cold, dry air mass. All right, so how does this have anything to do with water? Well, obviously it has a lot to do with water because it's producing precipitation. But so when we talk about precipitation can do either one of two or three things after it falls. So it can become runoff and go into surface water, which is what we're going to talk about now. It can infiltrate into the ground and become groundwater. Or if it falls as ice and snow, then it can get stuck at the top of mountains as snowpack or ice pack. All right, so if our incoming precipitation is really, really heavy, that's going to influence the volume of our surface waters. So obviously, if you dump a whole lot of water into a lake or river, the water level is going to rise. You're going to get more volume. If you only dump a little tiny bit of water into it, the water level might not rise so much. And if you don't have any rain for a very long period of time, no precipitation, your stream or your lake or your river might start to, get really small in volume. And then, so if we have more precipitation, we have more water in the surface water. So this could be associated with cold fronts or really long-term stationary fronts, because cold fronts dump a whole lot of water at one time, or stationary fronts stick around for a very long time and dump small amounts of water. And then if we have less precipitation down at this end of the spectrum, then we have less water added to our surface water. So this would be associated with like high pressure weather systems, because high pressure is associated with clear skies. The second thing that can affect surface water flow and volume is the permeability of the ground. So permeability is the ability of liquids to pass through something. So if we have something like a parking lot or hard clays or solid rocks, they're very low in permeability, so water cannot pass through them. So it's just going to run straight down and into the stream, and we're going to have higher surface water volumes in these situations when it rains. If you have a more permeable ground cover, like something that's covered with vegetation or sandy soils, then that water is actually going to be able to infiltrate into the soil very easily, and so it's going to get soaked up in the soil before it gets to the river. So the surface water is actually going to remain pretty constant in its flow or volume. Okay. So the third thing that affects surface water flow is the slope of the ground or terrain. So if we have really steep mountains, obviously that water is going to be influenced more by gravity, and it's going to run down those mountains really fast, and we're going to get a larger volume in our surface water, so in our stream or our lake. If the slope is really low, then gravity doesn't have much effect, and so the water is just going to kind of trickle on down into the stream, and your stream size is going to stay pretty constant even with rain events. So here you're going to get a pretty spiked increase with rain events, and then here we have a pretty constant water flow even with rain events. And then the fourth thing that influences surface water flow is the connectivity with the groundwater, so groundwater connectivity. So we can have two options. We can have a gaining stream, so that means that groundwater is actually flowing from the ground into the stream. Or we can have a losing stream, which means that the surface water from the stream or the lake is actually going down and infiltrating into the groundwater. And you can also have a situation where there is no connection with the groundwater and the surface water. And in that case, we just don't even consider this. We just consider the first three things. All right, so now we're going to apply these things in some stations.